Hi class, in lesson 4.6 we will be taking a look at long division of whole numbers. Learning targets for today will be estimating with quotients and developing an algorithm for dividing whole numbers. An algorithm is simply just a step-by-step procedure that we are going to use for calculating an answer. Let's take a look at page 280 and problem number 1. Let's look at some ways that we can use some organized guessing to help us with our division. Before you divide decimals, let's look back at what you have already learned about division of whole numbers. In elementary school, you learned that division helps you determine how many times one number is contained in another number. In other words, you determined the quotient if you were given a dividend and a divisor. The dividend is the number or decimal that is being divided into equal groups. The divisor is the number or decimal that divides the dividend. And finally, the quotient is the result of the division sentence. Quotients can be whole numbers, decimals, or fractions. So let's consider a few different examples to understand how division works. If you look at example 1, 48 divided by 6. I know that 6 times 8 is 48, so 48 divided by 6 is going to be equal to 8. Obviously, multiplication and division are inverse operations. You can kind of refer to this as looking at your fact families to help you come up with that answer for that division problem. If you look at example number 2, this is more of a guess and check method. You have the problem 582 divided by 6. So if you take a look at Chris's solution, he realizes that that's not a fact that he does have memorized, like in example 1 with fact families. So you have to use a combination of estimating and organized guessing. So like I said, this is more of a guessing and checking method. You can see that after several guesses, he finally does come up with the correct answer for the problem 582 divided by 6. Let's turn to page 281. If the division problem is longer or more difficult than one that we saw in example 2, then a guess and check method could be very time consuming. We know that that wouldn't be very efficient. So let's take a look at Lori's solution for the problem 34,098 divided by 6. So this should look similar to what you did in everyday math with partial quotients. First, Lori wanted to see how many times 6 went into 34,098. 6 went in 5,000 times, and then she ended up subtracting 30,000 from 34,098. Next, she wanted to figure out then, after getting the difference, how many times 6 went into 4,098. That would be 600. 6 times 600 is going to give you 3,600. You subtract and get the difference again. The third step that she had to take then was to figure out how many times 6 was going to go into 498. That was going to be 80 times. Again, she would get 480 and subtract the difference. And finally, for the last step, she saw that 6 was able to go into that difference of 18 3 times, and that ended up giving her no remainder. The last thing that she had to do then was add up all of her organized estimates for this strategy, and that would help her come up with her quotient. So when you add up all of those organized estimates, you see that 34,098 divided by 6 is going to give you 5,683 for your quotient. If you turn to page 282, you can see that Rob and Morgan agreed with Lori's logic, but they wanted to shorten up the process a little bit, try to make things maybe a little more efficient. In example 4, you can see Rob's solution is very similar to what Lori did. In example number 4, coming up with 5,683 for his answer. Morgan's solution in example number 5 is what we have talked about as far as using traditional division. With traditional division, Morgan saw that 6 went into 34 5 times. 6 times 5 is 30. When you subtract, you get 4 and bring down your 0. 6 goes into 46 times. 6 times 6 is 36. When you subtract, you get 4, bring down the 9. 6 goes into 49 8 times. 6 times 8 is 48. You subtract, you get 1, bring down the 8, and 6 goes into 18 3 times. So your quotient is 5,683. Now all of these are strategies that you can use to help with long division, but we are going to try and focus on using Morgan's method as we move forward in 4.6. Let's take a look at problem 2 on page 283. Carnegie Middle School conducted a month-long food and clothing drive to assist in disaster relief. They collected the following items for distribution. If the students want to make 256 disaster relief shipping crates, how many bottles of water will they put in each shipping crate? What I would like you to do with your group members to get started today is take a look at number 1, analyze each solution. You have Morgan and Dustin and what they did to carry out and try to figure out their answer. So take a look at Morgan and Dustin's solution with your group members and turn to page 84. Take a look at letter A and talk about what Dustin did do incorrectly. If you take a look at letter A on page 284, when Dustin was trying to solve this problem, when 256 would not go into 51, Dustin did not show a 0 in his quotient. Therefore, that led him to getting the incorrect answer. Let's go ahead and skip down to number 2 then. At the bottom of page 284, what I want you to do is use Morgan's method of long division to determine how many of each item must be loaded into each of the 256 shipping crates. So you can refer back to page 283 for the number of items. For letter A, you have cans of food. For letter B, you have blankets. And for letter C, at the top of page 285, you have batteries. So go ahead and take a couple of minutes with your group members to do A through C for number 2. If we take a look at letter A, when we use Morgan's method of long division, we end up with 52 cans of food. When we take a look at letter B, we end up with 37 blankets. And finally, if we take a look at letter C using Morgan's method, we would need 76 batteries for each shipping crate. Let's go ahead and move to problem 3. We are going to skip over to page 286 and start off with number 3. In problem 3, we're going to be focusing on what's left over, or talking about remainders when we have division problems. So if we take a look at number 3, it says the Red Cross Disaster Relief Fund collected 3,551 winter coats to distribute to flood victims. If there are 23 distribution centers, how many coats can be sent to each center? And Marla has her calculations then that are shown below. So take a look at the long division that Marla ended up carrying out for this problem, 3,551 divided by 23. Marla said that after she found out her answer, the Red Cross can send 154 and 9/23 coats to each center. Madison replied, "You cannot have a fraction of a coat, so each center will receive 154 coats and there will be 9 coats left over." So the answer should be written as 154, remainder 9. Go ahead and talk with your group members about who would be correct and why. After talking with your group members, hopefully you came up with Madison being correct. You can't have a fraction of a coat, so writing the answer with the remainder in this case would make more sense for this problem. Take a look at the bottom of page 286, very important in terms of division problems regarding remainders. It says, in division problems, the remainder can mean different things in different situations. Sometimes the remainder can be ignored, and sometimes the remainder is the answer to the problem. Sometimes the answer is the number without the remainder, and sometimes you need to use the next whole number up from the correct answer. In other words, you can round down if you don't use the remainder, and you can round up if you use the next whole number larger than your answer. So we're going to go ahead and work on a couple of problems to make sure that we understand this rule as far as using remainders with division problems. So let's take a look at the top of page 287. Number 4 says the Carnegie Middle School is hosting a picnic for any 5th grader who will be attending school next year as a 6th grader. The hospitality committee is planning the picnic for 125 students. Each 5th grader will get a sandwich, a drink, and a dessert. What I would like you to do with your group members is answer letters A through D on page 287 for number 4 based off of that problem situation. Read over the questions carefully. Make sure that you're understanding every part of the question that they are asking. Make sure that you're marking your text. So here is what letter A should look like for number 4. 125 divided by 8 is going to give you 15 and 5/8, or 15 remainder 5. Rhonda would be correct in this situation. They would definitely need to make sure that they round it to 16 so that everyone would have a sandwich. Let's take a look at letter B. The frozen fruit bars come in boxes of 12. How many boxes should they order? Will there be any extra, and if so, how many? So your division problem should be 125 divided by 12. That's going to give you 10 and 5/12, or 10 remainder 5. You want to make sure that you order 11 boxes, and when you order 11 boxes, there will be 7 fruit bars that are left over. If we take a look at letter C, bottled water comes in cases of 24. How many cases will they need, and will there be any extra bottles of water? 125 divided by 24 would be your division problem. Your answer would be 5 and 5/24, or 5 remainder 5. You would want to order 6 cases in this situation, and when you would do that, you would have 19 extra water bottles left over. And finally, if we look at letter D, each bus seats 32 passengers. How many buses will be needed to transport the students, and how many seats will be empty? Your division problem should be 125 divided by 32, which is going to give you an answer of 3 and 29/32, or 3 remainder 29. They would have to have 4 buses in order to transport the students, and 3 seats would be left empty. If you turn to page 288, I would like you to do numbers 5 through 7 for homework. Please make sure that you are showing all of your work. That is it today for lesson 4.6 on long division of whole numbers. Please let me know if you have any questions. Thanks.